So hi everyone. As I said, this is the first workshop. This is the introduction to GitHub, R, and clean code. And so let's get started. So first, what is Git or GitHub? This section is going to cover that, and also, but we'll start with a few terminal shortcuts. So for reference, terminal is kind of it's a way to like access a bunch of different your files. It's so you can run code through terminal. If you have a Mac or Linux computers, terminal is very helpful. If you have a Windows computer, your native terminal or command window is not great. But R, fortunately, does have a terminal window that we will be using. These are just some like quick shortcuts that you can refer to later. And some terms that I'll be using, or a term that I'll be using in the future is directory. A directory is essentially just a folder. Okay, so what is Git or GitHub? Git is a version control system. And basically what that means is that using Git, you can make changes to your code and return to your code. And if you have something that you mess up, you can basically return to a previous point in time in your code really easily. You can also create kind of different branches of code. And this is really valuable first for debugging. It can help you figure out where you went wrong. It's also really helpful because it like minimizes the risk of losing all your files. If you have a bunch of save points that you can go back to, if something accidentally gets deleted, you can easily go back to a point where it wasn't deleted. This is also very helpful for collaboration. You can when you're working with a lot of people, that like increases various risks. By using version control, you can kind of make sure that you're all editing what you need to be editing and that you're not like overlapping with each other too much. Essentially, there's a lot of reasons to be happy with version control, particularly when you get into writing some like complicated code. Most of what you'll probably be doing for O Economica, you'll probably want to for your eventual research project, but for the workshops, although we will be using Git and GitHub because that is how we're distributing the workshop materials, it's probably not like super essential that like your version control is on point for like these workshops. Okay, so two essential commands for Git version control are git add and git commit. So basically, when you have Git on your computer, when you make some changes to your file, you can save your file like normal, and then you use git add, which basically saves your stages your changes to be committed, and then you have git commit, and you have a commit message, which saves your changes as like a checkpoint that you can easily return to. And the importance of the commit message is paramount. It's very useful to have descriptive commit messages because then you'll be able to know what your save points actually are. Okay, so this is just kind of an example of when I was when I was running git add and git commit. So here you can see I used the dot as like an abbreviation for like everything in the file. And then you can see I did git commit, and here I had a commit message. And this is kind of what it showed after. It shows like what changes are actually being committed. So two additional essential commands are git status and git log, and these are really helpful, particularly if, like myself, you've used Git before, but you're not like necessarily, you don't have everything memorized or whatever. So git status will essentially tell you where you are and what you need to do, and git log will tell you your previous commits. It'll also like open up this annoying window to exit. You'll type Q and hit enter. So, but like for an example of git status, here's what it looked like when I typed git status in. So basically I made changes to all these files, and Git wasn't tracking them, even though I saved them like locally, right? And I could use, and I used git status to tell me, oh, I'm on the branch origin master, and I need to git add these files before I can commit. This is another example of git status. Here I had already committed my files. You can see some of the same writing up top that you saw maybe previously. And it also tells me where I am in comparison to like the origin master. We'll get a little more into what that is in a moment. And then this is like git log. It tells you what these each were. So right, so here you can see these are the commit messages: updated, readme, and created workshop one folder, et cetera, et cetera. And those and that's why commit messages are helpful, because then you can actually scroll back through and see like what commit you did what. Now, this is where Git gets really helpful, which is the branching, forking, pushing, and pulling. So branching is very useful for collaboration. It's useful for testing out new features or fixing bugs, and it decreases merge conflicts. And so the way you can see here that on the right-hand side, there's a kind of image of how this works. Basically, you have some code here, and maybe you want to test out a feature, but you don't know if you want to like mess up the rest of your code. You can create a branch and do a bunch of work in that branch, and then you can merge it back together at the end. And this will help, particularly if you're not certain of what of like how to like work it out. It allows you to kind of troubleshoot and problem solve without affecting your main code. So there's a bunch of commands involved in this, to be honest. And I don't think we're going to go through each one individually because, again, for O Economica, it will be helpful to have some of this knowledge, but it's not like you need to have this memorized. And personally, whenever I need to do this, I always like double check what it is anyway. But basically, the steps when you do this are you have to create a branch, and then you can like work and edit in that branch, and then you can merge branches to like let you know to like merge differences and merge changes. And so something important here is that before you merge your branch back into the original branch, you'll actually want to go the other way around. You always want to bring all the main stuff into your stuff to double check that your stuff works before you bring your stuff back into the main stuff, main branch. Okay, so after merging, and merging is going to be something that happens not just when you have different branches, but in a lot of different circumstances. By the way, if you have any questions at any point in time, definitely just like interrupt and stop me. Okay, so Git can often handle merges on its own. A lot of times you'll be working on code, and Git's pretty good at recognizing that, like, especially if your code has headers, that, hey, this is in a totally different section than this is. But sometimes there's going to be a merge conflict, and what occurs is basically there's two things that are kind of in the same place in your document. And so what Git will do is it will tell you there's a merge conflict, and you can open up really easily, keep the code you want to keep, and delete the rest. And over here on the right, you'll see kind of what this looks like. And the conflict will be outlined by this like kind of head branch thing. And it'll show you one version over here and one version down here, and you can pick what you want to keep. And this is why it's important to always merge from the main to yours first before you send yours back to the main, because once you make these merge changes, you're going to have to add and commit again, and then you can merge back to like have your final proper merge. Because what really Git prefers doing is it prefers keeping the main branch kind of the way it is without any merge conflicts, and you resolve like merge conflicts within your own within your own version of the code, essentially. So forking. So if you went through all the pre-workshop prep, forking is what you did to get your own workshop materials 2020 to 2021 GitHub repository. So this is useful, obviously, for like open source code, for certain kinds of collaboration. In order to update your materials, so for example, for workshops 2 through 7 and so forth, you will have to like do a pull request, but that's super easy to do on GitHub. Particularly since we're using GitHub for this, you can just do it in the browser. You don't need to worry about like writing any commands. There's also the workshop 1 accompanying materials has some instructions on how you can do this. This may require resolving some merge conflicts afterwards. However, I'll be putting the workshop materials kind of each in their own separate things, so you shouldn't need to resolve any merge conflicts when you pull to update your version of your fork of the workshop materials. If you do have any trouble with that in the future, definitely let me know, because that means I did something wrong, probably. Okay, so pushing and pulling. So this is really helpful. This gets your materials to and from your local repository, which is on your computer, and your repository on GitHub. You always have to pull first. And this can be something that's like easy to forget, and it's easy to like kind of get into like a mode where you're just working and you just keep pushing, except then if you're collaborating with someone and they're also pushing, you'll have some merge conflicts, and it's so much easier to resolve them on your computer than to like figure out what's up on GitHub. So Git push sends your materials to GitHub. Git pull pulls your materials from GitHub to your computer. And here's an example of Git push. I actually don't have an example of Git pull because at this point in time, I was just doing this like on my own computer for the most part. Okay, so honestly, Git's nice and all, but what you're really here for and what our workshops will generally be on will be R and RStudio. Because R is the statistical software, R is going to be how we run regressions, R is going to be how we create graphs, R is very helpful. You do not need to use Git or GitHub to use R. So first, you want to open RStudio. And this is what RStudio looks like when you open a blank RStudio. You have 4 panels usually. Your top left is going to be your files that you have open. You can see here I have Untitled 1 open. Or I have a picture of having Untitled 1 open. Down here, you can see there's 2 things. There's console and terminal. Right now, this is console. You can type code directly into console, test it out before you save it in your file. And console is where you actually run your code. So if you, for example, press the little run button there to like run the line of code that you have in your file, it's going to run down in the console and the output will come out of the console. And then terminal is actually a terminal window. Here on the top right, you have environment, history, and connections. History will tell you what is like what you previously run. Environment is going to tell you what variables and data you have saved under like what names. And then down here, you have a bunch of different tabs. You have files, which is what it sounds like. It shows you your files that you have. Plots is if you make any graphs, that's where those will appear. Packages, we'll get into packages a little later, but R is an open source software, which is great because it means, one, that it's free for us, but also it means that a lot of people have written various packages that you can add on to the base functionality of R to help you do more complicated things without having to like write functions and code it yourself. And so we're going to be using, we're definitely going to be using a lot of packages in our workshop series, and you'll probably be using a ton of packages throughout your time as doing economic research or really any research involving something statistical. Your help window is going to be very helpful too. It's what it sounds like. You can look up commands in your help window, and your viewer isn't particularly relevant. Okay. So now we're kind of going to be getting into what is like kind of the first quote exercise unquote of this, which is to set up your R project. So why use R projects? So if you go back to kind of here, you can see that there's like a little project symbol in the top right. And right now this says project none, because that's when I took the screenshot. But you can make multiple R projects, and basically each R project will kind of be its own folder, and you can switch back and forth with them in R without having to like close and reopen things. But you can also have multiple windows of R open in different R projects. It's really convenient because you can close and reopen projects to the same spot. It can help maintain project integrity, and it's easy to use with version control, which is particularly beneficial for us today. So the exercise, making an R project for your workshop materials. Okay, so what you're going to want to do is you're going to go back where I showed you there, the R project in the top corner, and you want to click on the project drop-down menu at the top right of your R window. Let me know if I'm going too quickly. It is the case that during the breakout rooms after this, we will kind of help you through this part if you want. But also here you can see a list of the projects that I have, which is why I'm not doing this with you in R, because I already have a project for the workshop materials. Anyway, so you can click on the new project, and this window should pop up. And you have 3 options. You have new directory, existing directory, and version control. So new directory and existing directory, remember directory just means folder. We'll basically start projects in new directories or associate a project with the current directory. But you'll want to click on version control because what you have right now on GitHub, hopefully, is a forked version of our O Economica Workshop 2020-2021 materials. And you'll want to be able to use that on your local computer and save your changes and pull from your version on GitHub to your local computer without having to like constantly be re-downloading things. And so when you click on create project from version control, you have Git and subversion. To be honest, I don't know what subversion is, but what you'll want to do is you'll want to click on Git. You'll want to clone a project from a Git repository. And then now you'll get a window like this with 3 blanks: repository URL, project directory name, and then create project as a subdirectory of. Yeah. So for your repository URL, you're going to go to your GitHub page on your personal account, and you have a forked version of the repository. So for example, I don't know what your username is, but it should have your username / the repository. And you can click on the green code button and press the clipboard to copy the link. And it should look something like this. It'll be like https ://github.com/ whatever your username is / workshop materials 2020-2021. And so once you have that copied, you just put that in the box titled repository URL. Your project directory name can really be whatever. That's going to be what appears in the little drop-down menu that I showed you earlier, that helps you switch between projects. But that's also going to be the name of whatever folder you're creating for this repository. And then, or folder that you're creating all of this code in, and folder that you're going to be saving all your files in. And then here, it's going to be a subfolder of whatever folder you have here in your create project as a subdirectory of. So here I actually have a folder called Economica Workshop Series that this is actually all in, which is why it's currently there. Whatever's here is what is the folder. The default for what's going to pop up here is going to be your current working directory, which is whatever folder you're currently in. But you can easily change that. You can just open up File and find the folder that you want, and then copy the little thing that'll tell you the address of that folder. So congratulations. Oh, you have to press create project. But congratulations, you've created your first R project. Okay, so now we're going to move on to really quickly to take a brief divergence to the importance of clean code. So what I mean by clean code is basically has to do with the readability of your code. And so why use clean code? It's more readable, it's more organized, it's better for collaboration, it's better for reproducing whatever you've done. And it's better if you have to return to a project later. If you make something now and I don't know, 3 years later, you have to return to it, you're not going to remember why you exactly did whatever you did to make your project work. It really helps to have clean code to be able to go back and see essentially what's actually going on. Okay, so at the project or directory or folder level, here are some best practices. First, you're going to want to have a data folder. The reason for this is that you want all your data to basically remain in essentially a read-only format and only edited through R or through another software. So if you download data, say from the census, you're going to want to keep that data as it is and not have to do any manual editing of Excel files. You want everything to be done through your software so it's easy to redo if you need to reproduce your work. It's good to have an output folder where you're basically saving everything that you've created. You might want multiple output folders depending on the size of your project, but this way you always know where to go to take anything that you've created in your code. This would often be graphs, for example, and tables. Ideally, all output should be able to be regenerated from the code. So you should be able to delete everything in your output folder and then run your code for the project and then have it come back again. Something else that's really, so in general, another thing that's very good is consistent folder or file naming practices. You don't want to have to guess what a file is. But I'm not saying that you need really long file names or folder names. Just the importance is really just being consistent. If all of your code files are labeled in the order that you run them, it's not necessarily the case that you really need the file names to be super, super detailed. I know some people who like having all of their kind of individual code files being named a little bit after what's done in that code file. So everything starts with a verb. Again, that's not necessary, but the important thing is that it's consistent, both for your personal usage, but also if you're working with a group of people that you're all kind of consistent there. Because that way also, if you're trying to go back and refer to a particular file in your code, you can do that fairly easily without having to do a bunch of going back and forth. Another important thing is readmes. There was one in the Economica Workshops 2020 to 2021 directory. It was a pretty sparse README, to be honest. But the importance of readmes is basically that it tells you what's in your folder, what's in your project, what the different files are, what's actually useful. All of that, all of that kind of information can go in a README. And it's kind of very standard practice to have these things that people can then like refer to later and be like, oh yeah, this, I can see what this does. And then of course, descriptive commit messages. I mentioned this earlier, but if you want to go back to a point in your code where your code did like X before you added something, it's really helpful to know when you added it through your commit messages. Okay, so now within your code, comments. I'll explain what a comment is in a moment. Doc strings and headers, logical organization, and then again, the consistent naming, and of course, later functions. But okay, so comments. Every coding language basically has a way that you can write a line of something in your document and press run on the file, and that line is not run. Those are called comments. You can comment things out. So like if something's not working, you can comment out a line of code and try and see if it works then to figure out where the bug is. But comments can also be used to just like explain sections of code, to be like, after this section does this, or like data section, cleaning data section, something like that. You can have comments throughout that can tell you and help people later figure out what you did with your code. Doc strings and headers are, you would write at the top of your document, you'd use comments for this as well, basically to just say what the document is, what the document is for. Within your code, a logical organization will help. When you're writing long things, as you probably will be doing in your cohorts, when you're writing your actual paper, it's going to be helpful if you like load all your data first and then do all your cleaning and then do all your kind of graphs and then do all your regressions, right? It's important to have your code be in a logical organization. That way, when you're going back to different sections, it's easy to figure out, oh, obviously I must have cleaned my data before making the graphs. That code should be before the graph making code, right? And then consistent variable data type function naming. So you're going to be able to like define a lot of variables or name your data, whatever, when you load it into R. You want whatever that is to be consistent, right? So if you have 3 different data frames and 4 different variables, you want your variable names to all be kind of following a certain pattern, and you want your data names to all be following a certain pattern, and you probably want those 2 patterns to not be precisely the same. It's also helpful to have these be at least a little bit descriptive. In a lot of examples online, you'll see R data frames referred to as DF. And that's great when you're looking at a generic example online. When you're actually doing something, say, again, maybe you're combining census data and jobs data, you'll probably have 2 data frames, and you'll probably not want them to be called DF1 and DF2 because you'll forget what they are. Or at least, I don't know, I do personally. Maybe you won't, but it's then very helpful to have one maybe called jobs DF and one called census DF. And then once you combine them, which you'll probably need to do again to run your regressions, you can call it like combined DF or jobs plus census or jobs and census DF, something like that, just to be consistent, but also to help you know what everything is. And then of course, functions. So R is kind of a fully functional programming language, is a fully effective programming language in the sense that you can write functions in R to do things that you can't do via the base R or via packages. What this means is that functions can help you not rewrite code. So if you know that you can like clean this particular data set this way, and you know that you have a bunch of data sets that look kind of similar, maybe you have a data set for every state, you can turn that into a function instead. But we're not going to get into that during today's workshop. Okay, so now we're just going to go to some examples in R. So I hope, is this very visible for you? I guess it's as visible as anything is on your screen because we're screen sharing. So before I even kind of jump into what these examples are, would anyone like to just kind of tell me one quick reason why this like introductory examples file is not an example of nice code?
Well, the variable names aren't very informative, are they?
Yeah, precisely. So one major reason here is that these are all just like random names. And I did kind of make them that way simply because I'm not really doing much with a lot of these variables. But yeah, it's definitely the case that these are not particularly helpful variable names. The document is kind of like organized in the way that I'll like intend to do things. But there's not a ton of commenting. There's not a lot of clarity. There's just kind of it seems like there's like a lot of just like individual pieces that are doing things. And that's because I'm
recording online.
Oh yeah, it should be. Lena, you back?
Yeah, sorry, my Wi-Fi
Oh,
just like died.
Yeah, before that, I mean, it is being recorded and we will upload it somewhere. So,
Yes.
yeah.
Sorry about that. Okay. Yeah, so these are some examples here. So the first several examples that I kind of highlighted are different ways to create variables in R. So something that's important to know is in R, there are 4 types of variables. There's numeric variables, there's integer variables, there's booleans, which are true and false, and then there's string variables. You also have different ways of having kind of NA or null, and those are treated in a couple of different ways, which will be very important when cleaning data. So what's important to know for creating variables is you can use this like little arrow thing that's simply a greater than followed by a little hyphen to assign a value to a variable. You can also use an equal sign. Your variables, by the way, do not need to be 1 letter long. They can be as long as you'd like. Well, probably not as long as you'd like. I'm sure that R does have like a maximum variable name length. But in general, as long as you need them to be to describe whatever it is you want. So when you're running code, there's a few different ways to do it. If you have your document open like this, you can click Control Enter, and you can see down here that that in the console, it says it assigns 1 to A, and then if you go over to your environment, you can see you under values, you have A and you have 1. And that will, and so that's just telling you have a variable named A, and that variable A corresponds to 1. Just as a reminder, down here you can see in the files, I'm in a folder where I have the workshop 1 folder, so I have these 3 files available. Yes, and so if you you can run by clicking Control Enter on a particular line. You can also run by clicking that little button there, and it'll run the line that you're on. This button is not going to run the whole file. See, actually, if you hover, you can see what it does. And so like, and this reruns your previous code. And so you can also, of course, highlight multiple code, a whole chunk of code to run it. And I'm just setting that up so that I can run through some of the other examples. So, like I said, there's a few different types of variables in R. So, so you see here, and there's a few different ways that you can see what these are. So, for example, type of will kind of give you a generic answer of what your variable is. And note, you can run by running something that you have written in the file, but like I said before, you can run by typing in your console. So if I want to do type of F down here, it'll print and it'll tell me it's a character. And that's because it's a string, right? So it's a character variable. You also have for different kinds of variable types, an is dot whatever, and that'll be like, that's essentially going to generate a true or a false, right? If A is a numeric variable, it will say true. And if A is not a numeric variable, it will say false. So for example, A is a numeric variable, so it says true. But E, which was 1.879, is not an integer, so it will say false. You can also do all sorts of operations with your variables. You can multiply, you can add. This little like symbol right here is modulo, so it'll tell you what the remainder is. So 45 divided by 3, the remainder is 0. And then you can also use various equivalencies to check the truthfulness or falsehood, I guess, of the statements, right? So if you want to check if A and B are equal to each other, you have to use 2 equal signs. If you only use 1, it'll assign whatever you have on the right to what you have on the left. So only using 1 is not particularly helpful, but you can, for example, do A equals B. Now, if you wanted to instead try like 1 equals 2 down here, it's going to tell you it's an error, because what that's going to try and do is it's going to try and assign the value 2 to the number 1, which you just can't do. But if you do 1 equals 2, it'll tell you false, because 1 does not equal 2. And you can see here you have a greater than b, you have a less than or equal to b, and you can also like stack these. So this is the not equal sign. Yeah, so the equal also works, I believe, for string variables, if I remember correctly. If you have at equals at, it gives you true. If you have cat equals dog, it'll give you false. Yeah, so the equals command can work for like all different kinds of things. You could also, by the way, do true equals false, and it'll tell you false. So like you can these methods of checking whatever it is that you're looking for, these equivalency, I guess equivalency is not the right word. These methods of checking for different kinds of relationships work across a lot of different kinds of things. So here, recall that we defined C as the Boolean value true. You can see C not equal to A less than or equal to B. And you can see that that's false because A is less than or equal to B, which is, A is less than or equal to B, which is true. And C is also true. So what you're trying to say here is true not equal to true? And that is false because two things that are true are equal in this sense. You can also compute the factorial of something. Basically, there's a lot of like kind of individual functions you can use. In fact, if you wanted, you could use R to replace your regular calculator. I guess it's nice to like practice using R, but maybe not super helpful because that's not really like the most useful use of R. And you also, R is maybe less portable than your calculator. So to kind of continue going, you can also create vectors and assign them values. And here's like where my code starts to get really annoying because all my vectors are also like just labeled with one letter of the alphabet. And you can create vectors with anything. So you can create a vector 1, 2, 3. You can create a vector 1 through 15. You can create a vector 12 through -12. If you use the little colon like this, it's generally going to assume that you just want all the integers kind of in order. So if I type z, I can see 12 through -12 as the vector, and that's telling you everything that's in your vector. You can create vectors of sequences. Here, and you can create vector by a sequence where you just tell it the beginning, end, and what you want the length to be. Right, so how are vectors different from arrays and lists? So, lists can contain more variable types. So it is the case that you can create a vector that has both strings and numerics. But you can, but your lists can contain arrays, they can contain data frames, they can contain a whole bunch of things. Separate from arrays, obviously a vector is just 1 by 1. I guess you could use not 1 by 1, sorry. A vector is just like 1 by n, as opposed to potentially being m by n. I guess you could use a 1 by n array as a vector, but it's generally, I think, easier in terms of functionality to just use a vector. I hope that answered your question. Okay, great, thanks. Right, so then you can create a vector of all zeros. Here, this creates a vector of 25 zeros. Actually, I just realized I need to run all of these because of some of my examples that I'm not sure if I'm gonna run. So some things you can do with vectors is you can refer to an element of the vector. So that's going to refer x of 1, the first element of the vector x, which it happens to be 1. Because remember, as you can see over here, by the way, everything that I've been running has been appearing as a value because I've been saving all these vectors and variables. Yeah, so this is like one of the reasons it's like environment is super helpful. By the way, if you wanted to clear everything, you could clear it like this. Something that's really important to know for R. R will overwrite values without warning you. So for example, you can see I have the variable, the letter A stored as, or the value 1 stored under the letter A. If I wrote A, 1, 2, 3, oh, oops. C, 1, 2, 3 to make it a vector. You'll see A now refers to the vector 1, 2, 3. And it did not tell me that like, oh, by the way, you're overwriting something you already have. This is another reason why it's good to have it's good to have somewhat descriptive names, because that decreases the chance of you like reusing the same name. Now, this is of course helpful for say for loops, that it automatically overwrites whatever it is, but it is really important to remember, because it's important to remember what names you've already used and what names you haven't. You can refer to things within a vector refer from the end to the beginning by using a negative number. Or actually, sorry, this is x minus the first. Sorry, I was confusing this with like Python. This is x minus the first item, right? So like x is 1, 2, 3. If you refer to x1, that's just the first element of x. If you refer to x minus 1, that's everything but the first element of x. Something that's important to note is that R indexes from the number 1, not from 0, which is different from other languages. But it's nice for like certain kinds of things, for like just counting and being somewhat intuitive in that sense, but it is important to recognize. You can refer to multiple elements within the same vector by using, again, like kind of the sequences thing. So if you have, remember the vector W is this vector. If you have W2 through 4, that refers from the second through fourth elements of W. You can ask for just a few elements of a vector in a particular order, right? So Z is this vector that goes from 12 to -12. If you ask for 1, 9, 4, you're actually going to get the first element, which is 12, and then the ninth element, which is 4, and then the fourth element, which is 9. Actually, it's a little weird that the 9 and 4 are like that. You can also index by a Boolean, right? So here, V greater than 2, if V had been a single value, right, that would return true or false, right? Recall from doing like A less than B. But instead, this actually indexes by that. So that gives you all the elements of V that are greater than 2. And essentially, these are all kind of different ways of indexing. There's some important commands here. Length tells you how long a vector is. You can add vectors. This adds them element by element. This creates a vector that concatenates them, basically puts the second one on top of the first. This, by the way, you can also combine a lot of these commands to make it into like one line. You don't always want to do that. Sometimes you want to keep them separately so that it's clear where what the logical progression is. But here, for example, that is if you created a vector of x and then added s onto the end, this will give you just the first 6 elements of that. You can run a bunch of commands. You can find the max, you can find the mean, you can find the min. Table is an interesting one. You get to basically tabulate all the things in it, right? So here, u plus t turned out to be a vector of all ones. You can table u plus t and get 25 ones. CumSum stands for cumulative sum. There's also cumulative means. I think there's cumulative max. There's some other ones. There's basically a whole bunch of different things you can do with vectors really quickly, just in like the base functionality of R. Now, of course, R is a statistical language, and one of the things that's very valuable about R, and you'll use it when in your statistics classes, is you can do a lot of like random number generations and things with probability distributions, and you'll be using them probably for your classes, right? So here, R unif1 draws one number kind of randomly from the uniform distribution. And so so here you have this is the uniform distribution from 0 to 1, since I haven't added, oh no, it's talking about my internet connection is unstable. Can you still hear me clearly? I am not hearing anything. I do not know
I
what.
believe there was a certain problem, but now it's better.
Okay, that's good. Yeah, I should figure out something with regard to my internet, but still haven't. Yeah, so you can draw multiple numbers at a time. So again, so in case what I said earlier wasn't clear, basically this RUnif function draws from the uniform distribution. If you don't use any of the extra options, the default is to go from 0 to 1, but you can change that. So for example, this next command here, this draws from 0 to 20. And you can see you've got the 3 different numbers randomly drawn from 0 to 20. If you just want integers, you can use sample. So you can do sample 1 through 100 and then get 3 numbers from that. If you already have a vector defined, for example, here we have the vector q is a, capital A, lowercase a, b. You can also sample from that, right? It doesn't have to be numeric. So that's where like sample can be very nice if you already have something defined and you want to just sample from it. Basically, all the kind of random number generations related to probability distributions follow a kind of pattern. So R followed by an abbreviation of the probability distribution tells you, or rather draws randomly from that probability distribution, right? So R norm gives you those 3 numbers because it randomly drew from the normal distribution. D norm, if I remember correctly, tells you the density, and P norm tells you the cumulative density. So what that means is that D norm is telling you essentially like the probability of drawing a 3 from the normal distribution. P norm is telling you the probability of drawing less than or equal to a 3 from the probability distribution. And then Q norm goes the other direction. As you know, as you may have heard, and we'll probably get into later, 5% is generally considered statistically significant. So here you can see with Q norm, the cutoff for 95% is 1.64 in a normal distribution. We'll discuss a lot more about like a little bit more about what these distributions mean and what they, in particular, what they mean for us when running regressions in upcoming workshops. So now you'll remember R can do a lot with strings as well. There's particular packages that are devoted to using strings, which add a lot of functionality. But even in the base R, you can still do things with strings. So for example, if we define A here to be O Economica and B here to be workshop, we can create AB, which is O Economica workshop with a space in between using this little like separation thing here and defining that as the space. You can count the number of characters in that. It's 19. You can also take a substring. You can take the first 5 characters. You can convert everything to uppercase, everything to lowercase. And this is all going to be probably helpful for you when cleaning data because you can find out because your string variables are usually messy and it's generally helpful to be able to clean them in these ways. You can move everything into like uppercase letters or lowercase letters. You can split the string. That splits the string at every space. You could split the string at anything else. For example, this splits the string at every O. And then here, A or AC is O Economica meeting. It's substituting it's substituting this string with this string in this string AB. Basically, there's a bunch of different things you can do with strings. They are generally helpful. They are not necessarily they're not necessarily like super complicated. Something that is in base R functionality that we're not going to get into in this workshop because it's a little more complex is grep, because that relies on regex expressions, and we're not going to deal with that right now. But the most important command to know in R is the question mark, because if you do question mark and then any command name, it'll pop up in your little help window and it'll tell you what that command is. So for example, here I wrote question mark floor and it tells you floor takes a single numeric argument X and returns a numeric vector. And you can see here, you can see the usage, you can see the argument, you can see some details, you can see some examples. And so this is obviously really, really helpful when learning how to use R, or even when you're not learning, even when you have some practice in, it's still really, really helpful to just know what these are. If I wanted to double check what R norm does, I can do R norm, and it'll tell me this is the normal distribution. Some commands have combined help files, so you can see D norm, P norm, Q norm, and R norm are all here. It tells you what arguments you can take in. It tells you what those arguments are. It gives you some details. It gives you some examples. Like it gives you some additional sources, right? So here these are links that'll take you to additional sources about the commands. So that was kind of a bit of an information download. So what we're going to do now is we're going to stop the recorded portion. We're going to move to breakout rooms. And in those breakout rooms, you'll be with upper level economics students who will help you figure out either how to finish the things from the pre-workshop prep or with some of these practice exercises. So these practice exercises should all be able to be completed using commands covered in these examples. And there's a bunch of them. They're like varying in difficulty. Some of them are super easy. Some of them are less easy. Obviously, there's no requirement that you finish all of them or anything like that. This is an RSO. This is not a class. This is just like a workshop that you're attending maybe for fun, but probably to help you learn R. And it's always good to get more practice in. Honestly, the best way to practice is to like do a project, but this is kind of a workshop and we kind of didn't really think of like a project that would work well throughout the whole workshop. So instead, you're going to have some like random practice examples. So with that, I'm going to stop the recording. If you have any questions before we move to breakout rooms, feel free to